Good morning to all. Today we are discuss about one of the gate topic, bipolar junction transistor from analog circuit under the scheme of AICTE PRANA. This scheme is very useful for higher education, especially for SC/ST students. I am JOTHIPPRIYA, Assistant Professor, Department of Electrical and Electronics Engineering, Erode Sengunthar Engineering College, Perundurai, Tamil Nadu. Now let us discuss today's topic, bipolar junction transistor. Bipolar junction transistor is one of the transistor and most important semiconductor device. Bipolar junction transistor also known as BJT or simply known as transistor. Bipolar junction transistor is mainly used to amplify the weak signal, and it is also used as a switch in digital circuit. Bipolar junction transistor is also called as bipolar device because the current conduction of the device depends upon the both type of charge carriers, electron and holes. The output current of the device can be controlled by input current. So it is called as current control device. Based on their structure, bipolar junction transistor can be mainly classified into two types. One is NPN transistor and another one is PNP transistor. The NPN transistor having two N region and one P region between two N region. The PNP transistor having two P region and one N region between two P region. From these two type of transistor, NPN transistor having higher mobility. So most of the application like amplify the weak signal and switching operation, we are using only NPN transistor. Now let us see the transistor construction. Transistor consists of two PN junction. The two PN junction formed by sandwiched either P-type or N-type semiconductor between the pair of opposite type. That means a transistor having two PN junction, the two PN junction connected back to back side to form a transistor. A transistor has three doped regions with three terminals, namely emitter, base, and collector. The emitter region is situated one side of the transistor, and it is heavily doped region. The main function of emitter is emitter charge carriers to the base. The next region is base region. The base region is middle region of the transistor. It is very thin region compared to emitter and it is lightly doped. The next region is collector region. This is situated other side of the transistor. The collector region is moderately doped region. The main function of collector to collect the charge carriers. Compared to emitter and base, the collector region physical place is very high. The transistor also having two junctions, J1 and J2. The junction J1 is formed between base and emitter, so it is called as emitter-base junction. The junction J2 is formed between base and collector, so it is called as collector-base junction. Figure shows the NPN transistor doping structure. In the figure, bottom is emitter region. The emitter region is heavily doped, so it has more number of electrons. The second region is base region. It is middle region. It is thin region and lightly doped region, so it has less number of holes. The upper region is collector region. It is lightly doped compared to emitter and moderate doped compared to base. It is moderate doped, so it has number of electrons less than the emitter. The space of the collector region is large compared to emitter and base. Figure shows the NPN and PNP transistor structure and symbol of PNP and NPN transistor. In the structure of PNP and NPN transistor, both the transistor has three terminals, emitter, base, collector, and three region, emitter region, base region, collector region, and two junction, emitter base junction J1 and collector base junction J2. Looking these two symbol of PNP and NPN transistor, both are in same, but only one difference, the arrow mark indication. In PNP transistor, the arrow towards the base. In NPN transistor, the arrow towards the emitter. The arrow mark indication indicates the flow of current direction. So, in PNP transistor, the current flows from emitter to base, whereas NPN transistor current flows from base to emitter. Now let us see the mode of operation of the transistor. Depends upon the external polarity biased voltage. The transistor can be operated in following three modes. The modes are cutoff mode, saturation mode, and active mode. In cutoff mode, emitter-based junction and collector-based junction are reverse biased. In saturation mode, emitter-based junction and collector-based junction are forward biased. The active mode, emitter-based junction is forward bias, collector-based junction is reverse bias. The cutoff mode and saturation mode of operation of the transistor is using switching application in digital circuit. The active mode of operation of transistor is used in application of amplifier circuit. Now let us see the working of NPN transistor. NPN transistor having two N region and one P region between two N region. In the NPN transistor, emitter is N type, base is P type, collector is N type. To study the working of transistor, the transistor is kept in active region. So, emitter based junction is forward bias and collector based junction is reverse bias. N type, so the N type emitter is connected to negative terminal of the battery and P type base is connected to positive terminal of the battery. Similarly, N-type collector is connected to positive terminal of the battery. P-type base is connected to negative terminal of the battery because collector base junction is reverse bias. The negative terminal of the battery repels the electron present in the emitter. So, the emitter electron moves towards the base. This constitutes a current named as emitter current. Junction J1 is forward bias, base is lightly doped thin region. So, emitter electron cross the junction J1 and recombine with holes present in the base region. This constitutes a current named as base current. Base is lightly doped, so it has few number of holes. So, few electron is used to recombine these holes. Remaining electron moves towards the collector and cross the junction J2. Collector is N-type. It is connected to positive terminal of the battery. So, electron present in the collector attracts the positive terminal of the battery. This constitutes a current named as collector current. So, in the transistor, emitter current is equal to base current plus collector current. That is IE equal to IB plus IC. Now let us see the working of PNP transistor. The working of PNP transistor is same the working of NPN transistor. The only difference in PNP transistor having two P region and one N region between two P region. In PNP transistor, the emitter is P-type, base is N-type, collector is P-type. Emitter base is forward bias, collector base is reverse bias, always in active region. So, P-type emitter is connected to positive terminal of the battery and N-type base is connected to negative terminal of the battery. P-type collector is connected to negative terminal of the battery and N-type base is connected to positive terminal of the battery. The positive terminal of the battery repels the holes present in the P-type emitter. So, that holes moves towards the base region. This constitutes a current named as emitter current. Junction J1 is forward bias, base is thin and lightly doped region. So, the holes present in the holes present in the emitter cross the junction J1 and recombine with holes present in the base. This constitutes a current named as base current. Base is lightly doped region, so number of electrons present in the base is less. So few holes is used to recombine this electron present in the base region. Remaining holes moves towards the collector. The junction J2 is reverse bias, but collector terminal is connected to negative terminal of the battery. So it attracts the holes present in the collector. This constitutes a current known as collector current. So in a PNP transistor, the emitter current IE equal to the base current IB plus collector current IC. Now let us see the transistor configuration. In any circuit, transistor is used. One terminal of the transistor is connected to input side. Another terminal of the transistor is connected to output side. One terminal is common between both input and output. Based on input terminal, output terminal, and common terminal, transistor can be connected in one of the following three configurations. The configurations are common base configuration, common emitter configuration, common collector configuration. Common base configuration means base terminal is common between both input and output. Common emitter configuration means emitter terminal is common terminal between both input and output. Common collector configuration means collector terminal is common for both input and output terminal. Now let us see the common base configuration. In the common base configuration, emitter is the input terminal and collector is the output terminal. Base terminal is connected to common terminal for both input and output. That means emitter terminal and base terminal are known as input terminals, whereas collector terminal and common base terminal are known as output terminals. In the common base configuration, the base terminal is grounded. So, this configuration is also known as grounded base configuration. Figure shows the PNP and NPN transistor common base configuration schematic diagram. From these two figures, input is applied between emitter and base, output is taken from collector and base. Input current is emitter current, output current is collector current, base is common terminal between input and output and is connected to ground. Now let us see the current amplification factor of common base configuration. The current amplification factor of common base configuration is denoted alpha. The alpha is defined as the ratio of output current to input current. Here the output current is collector current and input current is emitter current. So alpha equal to IC divided by IE. The current gain of the transistor is always less than unity. The value varies from 0.9 to 0.99. Now let us see the output current expression for common base configuration or collector current. The whole emitter current does not reach the collector because small percentage of current is used for recombine the holes present in the base region. So the collector current consists of large percentage of emitter current that reaches the collector terminal, that is alpha IE, and leakage current. This leakage current due to flow of reverse bias junction J2. So total collector current IC equal to alpha IB plus I leakage. From the above equation, the value of IE equal to 0, IC equal to I leakage only. The leakage current IC in this configuration is denoted ICBO. So collector current IC equal to alpha IE plus ICBO. But we know about IE equal to IC plus IB. Substituting the IE value in the IC equation, we get IC equal to alpha into IC plus IB plus ICBO. Expanding the equation and rearrange the equation, we get IC into 1 minus alpha equal to alpha IB plus ICBO. We need collector current, so IC equal to alpha divided by 1 minus alpha into IB plus ICBO divided by 1 minus alpha. So final collector current IC equal to alpha divided by 1 minus alpha into IB plus 1 divided by 1 minus alpha into ICBO. Now let us see the characteristics of common base configuration. The common base configuration characteristic schematic diagram is shown in figure. In this diagram, we are using two potentiometers for varying input and output current. One resistor is connected series to emitter to limit the emitter current. In the diagram, input is applied between emitter and base. Output is taken from collector and base. Input current is emitter current. Output current is collector current. Base is common terminal between input and output, and base is grounded. Now let us see the input characteristics. The input characteristics relates the input current and input voltage for various value of output voltage. In this configuration, input current is emitter current, input voltage is emitter base voltage, output voltage is collector base voltage. This input characteristics of the transistor is similar to forward characteristics of the diode. The input voltage is varied. The input current IE is varied linearly after the cut-in voltage. Figure shows the input characteristics graph. The graph is drawn between input voltage taking in x-axis, input current taking in y-axis for various value of output voltage. Here input current is IE, input voltage is VBE, output voltage is VCB. For small value of varying output voltage, the large value of emitter current is varied. Now let us see the output characteristics of the common base configuration. The output characteristics relates output current and output voltage for various value of input current. In this configuration, output current is collector current IC, output voltage is collector base voltage VCB, and input current is emitter current IE. The output characteristics consist of three regions. The one region is active region, another region is cutoff region, the next region is saturation region. In active region, collector current increase to a magnitude equal to emitter current. That is, in active region, IE approximately equal to IC or IC approximately equal to IE. In the active region, emitter base junction is forward bias, collector base junction is reverse bias. In cutoff region, emitter base junction is reverse bias and collector base junction is also reverse bias. The cutoff region is defined as the region whereas collector current is below the 0 amps. The next region is saturation region. Saturation region is defined as the region of the characteristics left from VCB equal to 0 voltage. In saturation region, emitter base and collector base junction are both in forward bias. Figure shows the output characteristics of common base configuration. The output characteristics is drawn between output voltage VCB and output current IC for various value of input current IE. In the figure, below the IE equal to 0 milliamps is denoted cutoff region. The middle region is denoted active region. In the active region, collector current is approximately equal to emitter current value. The region left from VCB equal to 0 is denoted saturation region. In the saturation region, the collector current linearly vary based on the applied input voltage. Here, applied voltage is VCB, collector base voltage. Now let us discuss early effect. Early effect means junction J2 is reverse bias. We are varying the reverse bias voltage. And the depletion layer across the junction J2 increased. The depletion layer increased, base width of the transistor is reduced. This effect is known as early effect. Further, we are increasing reverse bias voltage and the total base width equal to 0. This condition is called as punch through. In the punch through condition, transistor is breakdown. From the input-output characteristics, we get 4 parameters for common base configuration. The first parameter is input resistance. The input resistance is defined as the ratio of change in input voltage, here emitter base voltage, and corresponding change in input current, here emitter current, with the output voltage, here collector voltage is kept constant. So, input resistance Ri equal to delta VBE divided by delta IE at constant VCB. The input current of common base configuration is very low because it is forward bias junction. The next parameter is output resistance. Output resistance is defined as the ratio of change in output voltage, here collector voltage, to corresponding change in output current, here collector current IC, with the input current, here emitter current, is kept constant. That is R out equal to delta VCB divided by delta IC at constant IE. The next parameter is current gain or current amplification factor. Current amplification factor is denoted alpha. I already told. The alpha is defined as the ratio of output current to input current. Here the output current is collector current, input current is emitter current. So alpha equal to IC divided by IE. The value of alpha varies from 0.9 to 0.99. The alpha value is always less than unity. Now let us see the next configuration, common emitter configuration. In common emitter configuration, base is the input terminal, collector is output terminal, and emitter is common terminal for both input and output. That means base terminal and common emitter terminal are known as input terminal, whereas collector terminal and common emitter terminal are known as output terminal. In common emitter configuration, the emitter terminal is connected to ground, so it is also called as grounded emitter configuration. Figure shows the NPN and PNP transistor common emitter configuration schematic diagram. In the figure, input is applied between base and emitter. Output is taken from collector and emitter. The input current is base current, output current is collector current. Emitter is common terminal for input and output and is connected to ground. Now let us see the amplification factor of common emitter configuration. The amplification factor of common emitter configuration is also called as base current amplification factor, and it is denoted beta. It is defined as the ratio of output current to input current. Here the output current is collector current, input current is base current. So beta is equal to IC divided by IB. Now let us see the relationship between alpha and beta, that is current amplification factor of common base configuration and base amplification factor of common emitter configuration. We know beta equal to minus delta IC divided by delta IB. Alpha equal to minus delta IC divided by delta IB. We also know the emitter current IE equal to the base current IB plus collector current IC. Change in emitter current equal to change in collector current plus change in base current. From the above equation, we get del IB equal to del IE minus del IC. The value of base is substitute in the beta expression. We get delta IC divided by delta IE minus delta IC. Now we are dividing both numerator and denominator delta IE. Then we get beta equal to delta IC divided by delta IE in numerator divided by delta IE divided by delta IE minus delta IC divided by delta IE in denominator. The delta IE divided by delta IC equal to alpha. So substituting this, we get beta equal to alpha divided by 1 minus alpha. This is the relationship between beta and alpha. That is beta equal to alpha divided by 1 minus alpha. Now let us see the output current equation for common emitter configuration. We know IE equal to IC plus IB. We also know IC equal to del IE plus ICBO. So substituting IE value in IC equation, we get IC equal to 1 minus alpha into alpha IB plus ICBO. So the output current IC equal to alpha divided by 1 minus alpha into IB plus 1 divided by 1 minus alpha into ICBO. The collector current in terms of uh, beta value, IC equal to beta into IB plus ICBO, beta equal to alpha divided by 1 minus alpha. Now let us discuss common emitter configuration characteristics. Figure shows the common emitter configuration characteristics schematic diagram. Here also we are using two potentiometer. One is input side for varying input voltage and current. Another one is connected to output side for varying output voltage. Here, emitter is common terminal, so it is connected to ground. Input is applied between base and emitter. Output is taken from, here input, emitter is common terminal, it is connected to ground. So input is applied between base and emitter. Output is taken from collector and emitter. Input current is base current, output current is collector current. Now let us see the input characteristics. The input characteristics is similar to diode forward characteristics. The input voltage is varied. After cut-in voltage, the input current also varied in linear manner. In common emitter configuration, the input characteristics relates input current IB and input voltage VBE for various value of output voltage VCE. The graph is drawn between input voltage VBE taking in x-axis, input current IB taking in y-axis, and various value of output voltage VCB. Here, we are increasing output voltage. The base current is decreased due to early effect. Now let us see the output characteristics of common emitter configuration. The output characteristics of common emitter configuration relates output current IC and output voltage VCE for various value of input current IP. The output characteristics also consist of three regions: active region, cutoff region, and saturation region. The active region, the emitter base junction is forward bias, whereas collector base junction is reverse bias. The VCE is increased, reverse bias increase due to early effect. Very small change is reflected, very large change in beta. That is, alpha increases from 0.9 to 0. Alpha increases 0.98 to 0.985. Beta increases 34%, that is 66. That means alpha increases 0.5%, beta increases 34%. In the active region, emitter base is forward bias, collector base is reverse bias. Next region is cutoff region. Cutoff region is defined as below the IB equal to 0 milliamps. It is in the cutoff region, emitter base junction and collector base junction always reverse bias. Next region is saturation region. The saturation region is denoted left the VCE equal to 0 voltage. In saturation region, emitter base and collector base junction are forward bias. Figure shows the output characteristics of common emitter configuration. The output characteristics is drawn between output voltage taking x-axis VCE and output current IC taking y-axis for various value of input current IB. In the figure, the region below the IB equal to 0 is denoted cutoff region. In the cutoff region, emitter base is reverse bias, collector base is also reverse bias. So there is no current flows through the device. Only leakage current flows through the device due to reverse bias junction. In the figure, the middle region is denoted active region. We are increasing input current. That means IB also increase the collector current. But small change in alpha, greater change in beta. In the graph, the region left from BCE equal to 0 denoted saturation region. In saturation region, emitter base and collector base is forward bias. So this region is increased linear way. From the input and output characteristics, we get uh, three parameters for this configuration, common emitter configuration. The first parameter is input resistance. Input resistance is defined as the change in input current to change in output current. Here, the change in input current is VBE. Change in here the input current is IB, input voltage is VBE. So input resistance RA equal to delta VBE divided by delta IB at constant VCE. The next parameter is output resistance. The dynamic output resistance is defined as the ratio of output voltage to output current at constant input current. Here the output voltage is collector emitter voltage, output current is collector current. So R out equal to delta VCE divided by delta IC at constant input current IB. Next parameter is current gain. The common emitter configuration, the current gain is denoted beta. It is defined as the ratio of output current to input current. Here the output current is collector current, input current is base current. So beta is equal to IC divided by IB. Now let us discuss the next configuration, common collector configuration. In the common collector configuration, collector terminal is common between both input and output. Base terminal is input terminal, emitter terminal is output terminal. That means input is applied between base and collector, output is taken from emitter and collector. In common collector configuration, the collector terminal is connected to ground, so it is also called as grounded collector configuration. Figure shows the schematic diagram of common collector configuration for NPN and PNP transistor. In this diagram, input is applied between base and collector, output is taken from emitter and collector. Input current is base current, output current is emitter current. Collector is common terminal. It is connected to ground. Collector is connected between input and output. Now let us see the relationship between gamma, current amplification factor of common collector configuration, and alpha, current amplification factor of common base configuration. Current amplification factor of common collector configuration is denoted gamma. It is defined as the ratio of output current to input current. In common collector configuration, output current is emitter current, base current is input current. So, in common collector configuration, current amplification factor gamma is equal to delta IE divided by delta IB. That means change in emitter current to change in base current. Now let us discuss relationship between gamma and alpha. We know alpha equal to delta IE divided by delta IB. Emitter current IE equal to IC plus IB. Change in emitter current equal to change in collector current plus change in base current. From the above equation, we get base current delta IB equal to delta IE minus delta IC. Substituting base current value in the comma expression, we get comma equal to delta IE divided by delta IE minus delta IC. Now, dividing both numerator and denominator by delta IE, we get comma equal to delta IE divided by delta IE in numerator, divide by delta IE by delta IE minus delta IC by delta IE in denominator. Delta IE by delta IE equal to 1. Delta IC divided by delta IE equal to alpha. So, gamma equal to 1 divided by 1 minus alpha. This is the relationship between gamma and alpha. Now let us see the output current expression for common collector configuration. IC equal to alpha IB plus ICBO, that is large percentage of collector current reaches to emitter current reaches to collector plus collector leakage current, but emitter current IE equal to base current plus collector current. Substituting IC value in the emitter expression, we get IE equal to alpha IB plus ICBO plus IB. Simplifying this equation, we get IE equal to IB into 1 minus alpha plus ICBO into 1 divided by 1 minus alpha. Write this equation in beta terms. IE equal to beta plus 1 into IB plus beta plus 1 into ICBO. Now let us discuss input characteristics of common collector configuration. The input characteristics of common collector configuration relates input current IB and input voltage VCB at constant output voltage VCE. The input characteristics of common collector configuration is different from common emitter and common base configuration. This difference due to the fact of input voltage VCB. The VCE equal to VEB plus VBC, or VEB equal to VC minus VBC. So, the input characteristics of common collector configuration is always in linear manner. Figure shows the input characteristics of common collector configuration. The input characteristics of common collector configuration is drawn between input voltage VCB taking x-axis, input current IB taking y-axis for various value of output voltage VCE. Here we are increasing input voltage. Input current is also increased in linear manner. It look like this a straight line. This is difference between common emitter and common base configuration input characteristics. Now let us see the output characteristics of the common collector configuration. The output characteristics of the common collector configuration relates the output current IC and output voltage VCE for various value of input current IB. This characteristics is similar to common emitter characteristics, common emitter configuration output characteristics. Figure shows the output characteristics of common collector configuration. The output characteristics is drawn between output voltage VCE taking x-axis, output current IE taking y-axis for various value of input current IB. This characteristics is also divided as three regions: active region, cutoff region, and saturation region. The active region, emitter base junction is forward bias, collector base junction is reverse bias. It is in the graph, it is middle portion of the region. A cutoff region, emitter base and collector base junction is reverse bias. In the graph, it is below the IB equal to 0 value. The third region is saturation region. In saturation region, emitter base and collector base junction are forward bias. In the graph, it is situated left from VCE equal to 0 voltage. Now let us see the parameter of common collector configuration. The common collector also having three parameters. One is input resistance and another one is output resistance. Then next one is amplification factor of that configuration. The input resistance is defined as the ratio of change in input voltage to change in input current at constant output voltage. Here the input voltage is base collector voltage, input current is base current. So input resistance Ri equal to delta VBC divided by delta IB at constant VCE. The output resistance, next parameter is output resistance. The output resistance is defined as the ratio of change in output voltage to change in output current at constant input current. Here the output voltage is collector emitter voltage, output current is emitter current, input current is base current. So our output, that is output resistance, equal to delta VEC divided by delta IE at constant IB. The current amplification factor gamma is defined as the ratio of output current to input current. In this configuration, that is common collector configuration, the output current is emitter current, input current is base current. So gamma is equal to delta IE divided by delta IB. The common collector configuration current gain is very high compared to common base and common emitter configuration. Now let us discuss comparison of these three configurations based on their parameters. The parameters are input resistance, output resistance, voltage gain, current gain, power gain, and phase shift between input and output. So first parameter is input parameter. Input resistance. The input resistance in common emitter configuration is moderate level, common base configuration is low level, common collector configuration is high. The next parameter is output resistance. The output resistance of common emitter configuration is high, common base configuration is also high, common collector configuration is low. The next parameter is voltage gain. The voltage gain of common emitter configuration is high, common base configuration is also high, common collector configuration is low. Next configuration is current gain. Current gain of common emitter configuration is high, common base configuration is low, common collector configuration is very high. Next parameter is power gain. The power gain of common emitter configuration is high, common base configuration is moderate level, common collector configuration is low. The next parameter is phase shift. The phase shift angle between input and output of common emitter configuration is 180 degree, common base configuration is 0 degree, common collector configuration is also 0 degree. There is no phase shift between input and output. So now let us conclude the today's topic. Today we are discuss about transistor and transistor construction, working of transistor, mode of operation of transistor, configuration of transistor, input and output characteristics of uh, different configuration, and comparison of the transistor configurations. Okay, students, we will see next class. Thank you.